Good day, everyone. I am Kyla Salonga.
And I am Kirsten Diaz from Block 109, Section 5. Today, we would like to share with you these two experiments we conducted.
Let's begin. Eggplant, sometimes known as melogena, garden egg, or Guinea squash, is a nightshade that is commonly recognized in British English as aubergine. Eggplant is extensively used in cooking, most particularly as a key element in eggplant mixed with egg. Although eggplants are really not particularly high in any one nutrient, they do contain a wide range of vitamins and minerals including fiber, folate, potassium, and manganese, as well as vitamins, phosphorus, and pantothenic acid. Once you learn how good eggplant is for your health, you might want to think about making it as a regular part of your meal. Speaking of acid, a wake acid or a wake base can be used as an acid-base indicator. The color of an indicator does not shift from pre-acid to pure alkaline at a precise hydrogen ion concentration, but rather over a range of hydrogen ion concentration. The color change interval is a term given to this range. This is called the pH range. For the first experiment, let's start with the preparation of natural pH indicator. Peel 2 eggplants. Allow the peels to air dry for 1 to 2 days away from direct sunlight. Boil 250 ml of water. Then, remove from the heat. Soak the dried eggplant peels in the hot water. Place your sample of choice in a separate plastic cups and properly label them. Add 5 ml of water to each cup and mix thoroughly. The amount of sample used in water is 1 teaspoon. The amount of sample used in calamansi juice is 5 drops. The amount of sample used in baking soda is 1/2 teaspoon. Add 10 ml of natural pH indicator. Observe the color change. You may add more indicators if you want to observe a stronger color change. Research the pH of the samples used and determine which colors of the indicator would correspond to acidic, neutral, and basic solution. After adding 10 ml of natural pH indicator to water, it turned into light brown, which corresponds to the color of pH 2. After adding the 10 ml natural pH indicator to calamansi juice, it turned into dark brown, which corresponds to the color of pH 4. After adding 10 ml natural pH indicator to baking soda, it turned into dark brown, which corresponds to the color of pH 3.
For the second experiment, we'll be using a loom or tawas to stabilize more of the extract throughout the assessment. So, let's start again with the preparation of natural pH indicator. First off, peel 2 eggplants. Allow the peels to air dry for a few minutes. Next, boil 250 ml of water, approximately 1 cup, and then adjust it to medium heat. While boiling, soak the dried eggplant peels in the hot water and wait for 3 to 5 minutes or until most of the peels have turned a yellowish-green color. Then, add the pinch of alum powder or tawas into the solution or until the solution has turned a dark blue in color. Stir well while it's hot. Remove and filter the peels, allowing the remaining solution to cool before use. First off, place samples of choice in separate plastic containers and properly label them. In my case, I only have 3 containers, one of them containing water, shampoo, and vinegar. Then, we add half a spoonful to each container and mix thoroughly. The amount sample used in vinegar is 1 tablespoon. Amount sample used in water is 1 teaspoon. The amount sample used in shampoo is 2.5 drops. Lastly, research the pH of the samples used and determine which colors of your indicator would correspond to acidic, neutral, and basic solutions. For the results and discussion, after adding the 1 tablespoon of natural pH indicator to shampoo, it turned into a light lavender mixture in which it corresponds to a basic solution or pH 9. After adding the 1 tablespoon of natural pH indicator to vinegar, it turned into a light red mixture in which it corresponds to an acidic solution or pH 2. After adding the 1 tablespoon of natural pH indicator to water, it turned into a light blue mixture in which it corresponds to a neutral solution or pH 7. For the conclusion, as shown in the experiment, we use at-home kitchen materials to explore how the alternative sources can be used to detect the pH level of different mixtures by a pH indicator made from the eggplant extract. So, what's the science behind this experiment? The pH indicator that we made from the peels of eggplant has an anthocyanin, in which it is a weak acid that dissolves in water and produces various colors in a solution. When it comes in contact with different acids and basics, it identifies whether the specific solution is acidic or alkaline. Hence, only a small amount of pH indicator is needed for the solution to change in color over a narrow range of pH value. The results obtained from this experiment reveals a very promising application when indicating the pH values of a specific substance. The extract from the peeling of the eggplant exhibited different color changes in acid and basic solutions. So we have suggested that it is a suitable alternative or replacement for the synthetic indicators used inside the laboratory or science institutes. It is convenient, economical, and easy to use for testing the pH level of a particular substance. However, the only downside of using the peeling extract is that they need to be freshly formulated since they are prone to having fungal growth if exposed to air, reducing its lifetime.